In this video, we're going to look at the formula of alkanes. So we will look at the general formula of alkanes, then we'll look at how to work out the molecular formula of alkane, then the displayed formula of alkane, and then finally looking at the structural formula of alkanes. The first thing that we're going to look at is the general formula of an alkane and how we can use that to work out the molecular formula of an alkane. So the first thing to look at is the general formula of an alkane is CnH2n. Now this looks to be quite complicated at first, but really is quite straightforward. So the first thing that we need to do is we need to look at what Cn means. And all this means is Cn is the number of carbon atoms. Okay? That then means that H2n plus 2 is the number of carbon atoms multiplied by 2, and then we add 2. So if we want to look at an example, if we take something, an alkane with 2 carbon atoms, to work out the number of hydrogens, all we do is take the 2, multiply it by 2, which gives us 4, and then 4 plus 2 equals 6. So that then tells us that if we've got 2 carbon atoms, we have 6 hydrogen atoms. Again, we'll use the same rule, the same general formula. If we have an alkane with 3 carbon atoms, so propane, to work out the number of hydrogen atoms, we take the 3, multiply it by 2, which gives us 6, and then we do 6 plus 2 equals 8. So the formula is C3H8. Now, by working out the number of carbons and hydrogens, we're actually working out the molecular formula here. So the molecular formula just tells us the total number of carbon atoms and the total number of hydrogen atoms in the molecule, and we write it in the order of number of carbons, number of hydrogens. So we'll just look at one final example, and we'll look at if we have an alkane with 10 carbon atoms. So this would be called decane. And again, same rule applies. Number of carbon atoms multiplied by 2 equals 20. 20 plus 2 equals 22. That then tells us the number of hydrogen atoms is H22. So our molecular formula there is C10H22. So all alkanes follow that same general formula, follow the same rules. So if you ever need to work out the number of hydrogen atoms, you just take the number of carbons, multiply by 2, and add 2 to get the molecular formula. The next thing we're going to look at is this thing called the displayed formula. And you'll be able to see here, there's what looks like a diagram, and this is the displayed formula of butane. Now the displayed formula shows us the arrangement of the carbon and hydrogen atoms, and most importantly, all of the bonds between them. The important thing to remember about carbon is that every carbon atom can form 4 covalent bonds. So if we take the first carbon atom here, and we count up the number of bonds. So we've got 1, 2, 3, and 4 around it. Let's take the second carbon atom here, and we'll look at the number of bonds on this one. So again, 1, 2, 3, and 4. Now it doesn't matter if 2 carbon atoms share a bond between them, we just count it as 1 for each of them. Okay, so we can see there that everything, if we followed that pattern on, all the carbon atoms would be forming 4 covalent bonds. Now the important thing to remember about an alkane is it only has single bonds between the carbon atoms. So it's a single, or a carbon-carbon single bond. It's not a typo, it's not me saying carbon twice, it just means between 2 carbon atoms. Now the way that we draw the displayed formula is really easy. But first, we just need to know the molecular formula. So if we have the molecular formula of ethane C2H6, this tells me there are 2 carbon atoms and 6 hydrogen atoms. The easiest way to start drawing the displayed formula is to take the carbon atoms and put them side by side. We know it's an alkane because it follows that general formula of CnH2n plus 2, and its name is ethane, so it ends in ANE. So the first thing I do is I join the carbon atoms by a single covalent bond. I know that every carbon atom has to form 4 bonds, so then I draw my bonds around the carbon atoms to represent the 4 bonds, and then each of those must go to a hydrogen atom. And it's very important that when you're drawing these, that your hydrogens are capitals, because the symbol of hydrogen is a capital H. If you put a lowercase h, you risk losing the marks. So on to another example. Let's try C4H10. And this is butane. Again, I'm going to start by putting my carbon atoms in a row. Now this is the same as the one above, but I'm going to show you how to draw it. So again, carbon atoms in a row, link them all, or join them all together with a single bond, and then make sure that each of your carbon atoms has 4 bonds, and each of those ones around the outside goes to a hydrogen atom. So making sure that we've got capital H's for hydrogen. And then if I compare that back to my structural formula, 4 carbon atoms and 10 hydrogen atoms. We'll do one more example and we'll look at C3H8, which is propane. Again, 3 carbon atoms, put them in a line, join them together with a single covalent bond, and then put the other bonds around the outside, which then go to hydrogen atoms, remembering the capital H's. And now I've got C3H8. The other useful thing to remember is once I've got a displayed formula, it's really easy to work out the molecular formula. So if I go back to my example that I showed you at the beginning of butane, I can see here that if I count up the number of carbon atoms, carbon atoms equals 4, and hydrogen atoms equals 10. Therefore, the molecular formula is C4H10. Now we're going to look at structural formula. Now the structural formula shows how the carbon and hydrogen atoms are arranged, but without drawing the displayed formula. So I'm giving you the example here of ethane. So here's the molecular formula of ethane, C2H6. And then this is a structural formula. I'm going to show you where this comes from by drawing the displayed formula of C2H6 of ethane. So as we did before, carbons in a line, and then each of those bonds around the sides to hydrogen atoms. Now we can see here that it says that the structural formula is CH3CH3. All this means is that I take the carbon atom on the left, and if I separate that out, I can see here that I've got 1 carbon atom surrounded by 1, 2, 3 hydrogens, which is CH3. And then if I take the second carbon atom, again, I've got 1 carbon atom and 1, 2, 3 hydrogen atoms, so that becomes CH3. So my structural formula there is CH3CH3. This just shows me the arrangement of the carbon and hydrogen atoms without having to draw the full displayed formula. So if we take another example, And if we take the example of propane, which is C3H8. So to work out the structural formula, I'm just going to draw the displayed formula, sorry. So 3 carbons, link them together with single bonds because it's an alkane, and then I'm going to put my hydrogens in. Now it's really important that you do put the hydrogens in. Sometimes do see people forgetting to put them in, and you will lose the marks if you don't do that. Now I'm going to do exactly the same as I did before, and I'm going to get the structural formula by looking from left to right. So the first one, the first carbon atom, is 1 carbon and 3 hydrogens. So that would be CH3. The second carbon atom is slightly different here, because this one is 1 carbon atom and 2 hydrogen atoms. So I write that as CH2. And then the final carbon atom on the right hand side is 1 carbon and 3 hydrogens, which shows me that that is CH3. Okay, we'll do one more, and this will be butane, which is C4H10. Again, start with the displayed formula. 4 carbon atoms joined together by single covalent bonds, and then all I'm doing is putting in my hydrogen atoms. Make sure, again, capital H is for hydrogen, and make sure you don't forget to put any in. Then I'm going to start to look from left to right. So first carbon atom, just like before, is CH3. Second carbon atom is CH2. Third carbon atom is CH2. And then the last carbon atom there is CH3. So there we have it. You can now work out, if you've got the molecular formula and you remember how to draw the displayed formula, you can work out what the structural formula of an alkane is. So just to summarise, the general formula of an alkane is CnH2n plus 2. All that means is take the number of carbon atoms, multiply it by 2, and then add 2 to work out the number of hydrogen atoms. Molecular formula, that's the total number of carbon and hydrogen atoms in a molecule, always beginning with C and then H. The displayed formula is a diagram showing how all of the carbon and hydrogen atoms are arranged with all of the bonds, and that's really important to remember that we do show all of the bonds and the correct symbols, particularly hydrogen with a capital H. And the last one there is that we've got the structural formula, and examples there are CH3CH3 and CH3CH2CH3. That example there of CH3CH2CH3 actually shows this molecule here, which is propane. Okay, well, I hope you found that useful.